Viewers, let's solve the question on the board. Represent the complex number z, which is equal to negative 10i in the polar form. Okay, we know that complex number z is represented by, we have the real number part. Here we don't have the real number part, so that will be 0, then minus the imaginary, which is what? Negative 10i. So let's find for the modulus. My modulus r is equal to the square of the real number part, which is 0 squared, then plus the imaginary part, which is negative 10 squared. So I have r to be equal to what? 10. Straight away, right? So the angle theta is given by tan inverse of imaginary, which is negative 10, over the real, which is 0. And when you compute this, what value are you getting? This simply gives us what? An undefined what value. This is undefined. So have you seen the limitation over here? Calculator can't go beyond this scope. As a result of that, we need to employ the Argand diagram to continue. From here, see the relevance of Argand diagram is very, very, very key. So this, you can't solve for this. So let's see, this is undefined. This is very, very funny. Let's see how Argand diagram can help us here. So when I just do this, let's plot here, negative 10i comes here. I have here to do what? I have negative 10i. So if I move from here to here, from here to here gives what? This is 90 degrees, right? From here to this also gives what? 90 degrees. Or simply the total angle over here is what? 180 degrees. Then from here to here is also what? 90 degrees. So the angle over here will be 90 plus 90 plus 90 what? Degrees. So therefore, my angle theta is equal to 180 degrees. So if it is undefined, this is how we go about it. So we don't just say the question is wrong. Okay. So to represent this in polar form, z is equal to, in polar form, r multiplying cos theta plus I sin theta. Okay. I have z is equal to, my r is what? Is 10. The cos of, viewers, there is a mistake here. 90 plus 90 plus 90 gives 270. Okay, so I have, so 90 plus 90 plus 90 gives what? 270 degrees. Okay. So in polar form, you know this formula, right? So 10 multiplying cos of the angle, which is what? 270 degrees. Then plus I sine 270 degrees. Viewers, this is the end of this simple question. Viewers, let's tackle the last question regarding Argand's diagram. Okay, so write this complex number in the polar form. This is the same as z is equal to negative 3 and half square root of 3 plus I, all over square root of 4 is what? Is 2. Then you multiply this by that and this. Okay, so I have z is equal to half negative 3 root 3. Then I have negative 3i all on 2. So z is equal to, this is the same as negative 3 on 2 root 3. Then minus 3 over 2. Then I have what? My I over here. So this is, you just simplify this to this. Now, the angle theta is given by tan inverse of this over this. Is that also? So we have negative 3 on 2, then all over the whole of this. I have negative 3 on 2 root what? Root 3. So negative cancels negative. This 3 cancels 3, 2 cancels 2. I have 1 over here. So theta is equal to tan inverse of 1 over root 3. So theta is what? 30 degrees. Is this the actual angle? Yes or no? Let's find out. I have x here, I here. So this side, I have my real part here and my imaginary part here. Negative, negative, right? So which region has negative x and negative y? So quadrant 3, right? 1, 2, 3. So my x here, we have negative 3 root 3 on 2. And this is my y. So I have 3 on 2, okay? So negative here. So if I do this is the point of intersection. If I draw a straight line to pass through the intersection, okay? So this is R, my modulus. My modulus was what? We didn't look for the modulus, okay? But it's nothing. Let's solve for the modulus over here. So the modulus R is equal to the square root of, that's the square of the real part plus the square of the imaginary part, okay? So I have negative 3 on 2 root 3 all squared, then plus we have the imaginary part to be negative 3 on 2 all squared, okay? So R is equal to square of negative 3 gives us what? It gives 9. Then square root of 3 all squared gives what? It gives 3. Then all over square of 2 gives what? 4. Then here I have plus square of 3 gives 9 over square of 2 gives what? 4. So R is equal to, I have this by this gives 27 over 4. Then plus 9 over 4. So R is equal to 36 over 4. So I have R is equal to square root of 36 is what? 6 over square root of 4 is what? Is 2. So R is equal to what? Is equal to 3. So therefore we have the modulus and we have the angle, okay? So I can say that R is equal to square root of, no, I can say that my R is equal to what? My 3. And this will be my angle, okay? My angle theta. So you ask yourself, is this the actual angle? Yes or no? From the Argand diagram, we can tell. We can tell. So now, from this region to this region, you have theta is equal to 30 degrees, right? When you compute this. So now, is this the actual angle or not? Let's confirm using the Argand diagram. So my argument, which is my R, my reference angle is equal to, because we are working in the third quadrant, the angle theta is given by 180, then plus what? Plus theta, okay, or alpha, which is equal to 180 plus the angle I had here, 30. So therefore, my argument is equal to 210 degrees. As simple as that. Let's represent this in polar form. So in polar form, Z is given by R, then I have what? Cos theta plus I sine theta, as we've been doing it all the time. So Z is equal to the value for R, okay? So viewers, this is R, which is 3. So I have 3, then I have cos of the angle theta, which is what? 210 degrees plus I, then sine what? 210 what? Degrees. Viewers, this is the end of the tutorials on Argand diagram. So far as this YouTube channel is concerned, we are going to learn a lot. Stay alert for more updates. Bye.